Welcome to Ask and Learn.
Alright guys, to solve this problem, we first need to use the given temperature, that is T1 is equal to 20 degrees centigrades, the relative humidity, that is phi1 is equal to 70%, and the pressure, that is P, is equal to 96 kilopascal. To determine the vapor pressure PV1 and from that the dry air pressure PA1, so PV1 is equal to phi into PG1 is equal to 0.7 multiplied by 2.3392 kilopascal is equal to 1.6374 kilopascal. Then we have PA1 is equal to P minus PV1 is equal to 96 minus 1.6374 is equal to 94.363 kilopascal. Now we can calculate the absolute humidity W1 and from that the enthalpy H1. So for the calculation we will also need Hg1, that is equal to 2537.4 kilojoules per kg. Then we've got V1 is equal to 0.622 multiplied by PV1 divided by P minus PV1, and that is 0.622 multiplied by 1.6374 divided by 96 minus 1.6374, and V1 W1 is equal to 0.011. So H1 is equal to Cp into T1 plus W into Hg1. So it's 1.005 multiplied by 20 plus 0.011 multiplied by 25, 37.4, and H1 is equal to 48.01 kilojoules per kg. Next, we can calculate the specific volume V1, that is equal to RA into T1 divided by PA1, that is equal to 0.287 multiplied by 293 divided by 94.363 is equal to 0.89 cubic meters per kg. We will also need the same parameters for the exit flow. First, we need to use the given temperature, that is T2 is equal to 35 degrees centigrades, and the relative humidity, that is phi2 is equal to 100%, and the pressure P to determine the vapor pressure, that is PV2 is equal to phi multiplied by PG2 is equal to 1 multiplied by 5.6291, that is equal to 5.6291 kilopascal. Now we can calculate the absolute humidity W2, and from that the enthalpy H2. For the calculation we will also need Hg2 is equal to 25 2564.6 kilojoule per kg. Then we have W2 is equal to 0.622 multiplied by PV2 divided by P minus PV2, and it's 0.622 multiplied by 5.6291 divided by 96 minus 5.6291. So guys, W2 is equal to 0.03874, and H2 is equal to Cp into T2 plus W into Hg2. Then we have H2 is equal to 1.005 multiplied by 35 plus 03874 multiplied by 2564.6, and H2 is equal to 134.52 kilojoules per kg. We will also need the enthalpies H3 and H4. For the calculation, we will use the given temperature, that is T3, which is equal to 40 degrees centigrades, and T4, which is equal to 30 degrees centigrades. So H3 is equal to 167.53 kilojoules per kg, and H4 is equal to 125.74 kilojoules per kg. Next, we can take the energy balance equation and solve it for the needed mass flow rate Ma. For the calculation, we will need the given mass flow rate of water, that is M3 is equal to 17 kg per second, that is equal to 0 is equal to Ma H2 plus M4 H4 minus Ma H1 minus M3 H3. All right, guys. Next, we have 0 is equal to Ma into H2 minus H1 plus minus Ma into W2 minus W1 plus M3 into H4 minus M3 H3. So Ma is equal to M3 into H3 minus H4 divided by H2 minus H1 minus W2 minus W1 into H4. It's H4. So guys, now we put the values over here. So it's Ma is equal to 17 into 167.53 minus 125.74 divided by 134.52 minus 48.01 minus 0.03874 minus 0.011 multiplied by 125.74. So guys, the answer to Ma is 8.56 kgs per second. So moving further with the mass flow rate, we can now calculate the volume flow rate. So that is V is equal to Ma into V1 is equal to 8.56 multiplied by 0.89 is equal to 7.62 cubic meters per second. And also we can calculate the mass flow rate of the makeup water, that is mm is equal to ma multiplied by W2 minus W1 is equal to 7.62 multiplied by 0.03874 minus 0.011. So guys, the answer is mm is equal to 0.21 kgs per second. So guys, these are the answers to this question. I hope you have easily understood all the calculations as well as the formulas. Thank you very much.